Artemis is the next big project for NASA relating to the moon and astronauts in space. It's to do exploration, but it's also to show how to live and work in space, have a sustained presence in deep space, in this case on the surface of the moon, and be able to sustain that presence. Artemis will put astronauts on the moon in the next few years, perhaps. That's the plan. And there's yet another aspect that's coming, and that's commercialization of space. It's going to be tens of billions of dollars put in, if not hundreds of millions of dollars, put into these kinds of activities. I've been studying the moon for over 30 years, and I'm part of a, let's call it a national or even an international consortium of scientists who are interested in studying the moon, developing the moon, getting a sustainable presence on the surface of the moon, getting back to the moon.
3, 2, 1, 0.
When I started this, Apollo had just finished when I started my career, and I thought that we would be back on the moon within a decade. Well, here we are 4 decades later, 5 decades later, and we're still not back. But I would imagine by 2025, 2026, we're going to see NASA preparing to put astronauts back on the surface of the moon. And that very first mission will include exploration on the surface, but return of key samples. And I would be very interested in the next set of lunar samples. I've been involved for many years in NASA's committee that works on understanding and developing plans for the analysis and distribution of lunar samples. And certainly at Washington University, we have the laboratories and the people to make a very compelling case to get samples back in our laboratories and study them, as we have been since the Apollo days. We have samples from Apollo, we have samples of lunar meteorites, and in fact, that's what I've been doing for the past 30 plus years, is to study lunar samples. So it's very much in our interest at Washington University to be playing a role in the return of samples. We learned so much from the Apollo missions, and Artemis, with astronauts going back to the moon, can do the same kinds of things. And we're looking at a location near the South Pole, so we can get at some of these ices and find out for sure, is this something we can use in the future for sustainability on the moon? A supply for water, a supply of oxygen and hydrogen that can be used for fuel, as well as life support, and showing how to do these things beyond low Earth orbit. That's where all of our experience is now, except for Apollo, is in low Earth orbit. And we need to show how to do this beyond low Earth orbit, beyond the protection of the Earth's magnetic field, and for sustained periods of time. We know the ices are there, but we need to know more about them. And I think in the next 2 to 4 years, we're going to learn quite a lot. There is a robotic mission coming up called Viper that will explore with a rover, and following that will be humans. We're not just going to go for 2 or 3 days. We're going to go for weeks, months, and eventually have a permanent presence. And it can be used as a stepping stone, if you will, to exploration elsewhere. For instance, very expensive to get all of the fuel you need into space to a mission with astronauts to go, say, to Mars. But if we could get the fuel from the moon, it's much less expensive because the moon has much less gravity. So we could go to the moon, launch from there with oxygen and hydrogen derived from the regolith. We need to prove that to make it happen. If I didn't think there was a possibility of sustainability, I wouldn't be so interested in this. But there is, and we will figure it out. We will develop the means to do this sustainably. It may take a decade or more to figure it out, but I believe we will.